The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, ladies and gentlemen. Welcome to TechGig webinar series, our endeavor to empower techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is NoSQL DB, the changing face of data storage. And our guest speaker today is Sujit Muniandi. He is the Product Specialist, Center of Excellence for IBM Social Business at TCS. Sujit is Product Specialist at Tata Consultancy Services, Technology Excellence Group from IBM Social Business with an IT experience for over 5 years. Technological Evangelist with expertise on APIs, portals and SOA. So, without further delay, I introduce you all to our guest speaker. Over to you, Sujit.
Thank you, Aradhana. Thank you. Good afternoon to all. So today, welcome to today's TechGig webinar. So today's session would be on NoSQL DB, the changing phase of data storage. So the agenda for today's session, we will be covering the introduction on why we need SQL DB or NoSQL DB, then the NoSQL DB's data model and how it impacts the recent technologies like cloud computing, mobility, and big data, and the advantages and the disadvantages that are linked with NoSQL DB, and also a comparison between NoSQL versus the SQL, the relational database management systems currently in place. And then we can proceed to the question answer session. So outcomes of this session, ideally after the session you would be able to understand the differences between NoSQL database and the relational database management systems, the current trends that drive the need for the new database model, ideally the current trends such as mobility, again cloud computing, and big data, which are quite impacting the latest internet technologies. So these trends, how they are looking at a new database model, so we'll be looking at it. And the next one is how NoSQL DB benefits the internet technologies alongside elastic scalability feature and sharding. And also we'll look at the currently available NoSQL DBs that are available on as a service on cloud, and also what are the considerations in using NoSQL DB, and also why we should go for NoSQL DB. Now the synopsis. See, over the recent years, if you have noticed, the data that is being stored or collected and analyzed has been huge. Ideally, in an internet environment, the data that is stored is in terms of exabyte. In 2006, almost 161 exabyte of data was stored, according to a study. But in 2010, almost in 4 years, the increase was about 500%, which is close to 1,000 exabytes. If 1 exabyte is ideally equal to 1 billion gigabytes. So that much of data has been collected and stored over the recent years. And the phenomenal increase in data is primarily due to the new concepts that have arisen, which are like mobility, big data, and cloud. The volume of data that is flowing is huge, and it becomes it becomes very complex to store them, process, and also analyze the data. So in recent times, the most the popular concept that is used is NoSQL, or it's otherwise called as non-relational databases. So this can also be considered as a viable option to relational databases, mainly for interactive web and mobile applications. So if we look at banking application, wherein consistency is the key, NoSQL wouldn't fit in. But in case of like an insurance application where we have to store a lot of huge amount of data, which is not really that much consistent as compared to a banking application, a NoSQL database could be helpful. To give an example, MetLife, it had been trying for over the past 10 years to have a unified customer view, but then they achieved it of late with NoSQL DB. Ideally, they used MongoDB, which is one of the NoSQL DB, to achieve this unified customer view. Now we'll get into the introduction of NoSQL DB. Ideally, this session would not be, it would be comparing SQL or the relational database management system with NoSQL databases, but then it will not contradict or criticize RDBMS. It will ideally tell why NoSQL could be considered as an alternative, but not it will not discard or disregard RDBMS. So SQL databases, so ideally IBM, Sybase, Oracle, and to lesser extent Microsoft were the mainstay, which were primarily helping in data storage. The basic features of SQL Server, it is completely tabular structure. So all the data is defined into categories, and the data is stored as an instance. So if you take a table will ideally contain the data, and then each row will have the instance of the data, and each column will define the data categories. So user or the applications will access the data from these tabular structure, and it will use them for processing and analyzing the information. In case of SQL databases, there are certain limitations such as scalability and complexity. When you say scalability, when the huge amount of data is pulled in, the scalable factor like increase in capacity of RDBMS is limited. Also, the complexity primarily impacts the performance. More and more data is stored, the hierarchical structure of the data is increased. So in order to process or retrieve the data from the database becomes incredibly difficult. So in those cases, again, there is a trade-off with the performance. So these type of complexities have, were available, were there with RDBMS. Another introduction is like why there was an impact on data management. Of late, there was a recent study which concluded that there was almost 40 billion per year spent on databases, and much more of cost was put in for the resources that manage the databases. Also, if you have noticed, over the recent times, there were changes in the applications that we use, the environment that we use, or the data that we use. Like previously, if you take applications, in olden days, we used to use PHP, C, or Java to write. Now we go to Ruby or Groovy to completely, the techniques that we use is predominantly changed. Again, in case of environment, previously applications were developed for single users and it is put onto the desktop and run. Then comes the entire architecture where the data center was set up, the environment, those applications were deployed onto the servers in the data center, and then they were hosted. Of late, we primarily move towards the cloud architecture where some other organization provides the infrastructure or even the software as a service, and we use them. But if we look at the database or the data that is, or the data storage, there is predominantly not, it has not changed over the past 30 to 40 years. It's has always remained the same, which is the relational database. And normalization has been the predominant technique that was used for enhancing the performance. So we split the data into hierarchical structure and then use them to retrieve and then process our, use it for our applications. And in recent times, the impact on data management has been primarily due to increase in the number of concurrent users. Nowadays, we all use mobile apps, desktop apps, and the increase in the number of apps and increase in number of mobile phones that we use, the concurrent usage and the applications demand has become immensely big. And also the data that we are collecting and types of data that we are collecting has also changed. Nowadays we get JSON. When you're using mobile applications, most of the time we go for a JSON related data and we try to process them and try to retrieve the data and then dump it into our database. Again, the richness of the applications with Twitter, Facebook, all we use is like most of the social networking sites have completely brought up this unstructured and semi-structured data. For example, if you're in a location where we are using a mobile app and we want to find a restaurant in a nearby place, so those the restaurant data is again collected and it's fed into our system and we have to process that. So for each user, based on the location or based on the preference, huge amount of data is being collected. So there is a lot of data that has to be processed for even for a simpler application. And also the advent of integration between multiple systems using API approach has gotten huge amount of data that has to be analyzed. Now we'll look at what is a NoSQL DB. Ideally, the term was coined by Eric Evans. It actually doesn't mean NoSQL, which is not like no queries or nothing. It ideally means not only SQL. So you can have queries as well, and also the data can be stored in a different structure. The NoSQL term is ideally, it belongs to the non-relational data storage systems as opposed to the relational database systems. And the concept here is most of the that NoSQL DBs doesn't have fixed table schema. So it's a schemaless approach. So like when we have relational database management, RDBMS, we have multiple tables and we use joins or views. We create a view or join data from two different tables and then use the data for our applications. But in case of NoSQL DB, there is no fixed schema. So ideally, the dynamic schema would help us in accessing the data faster, so it helps in improving the performance. And the NoSQL DB is an alternate, or you can say a combined approach with RDBMS. It's one other approach that can help in data management, data storage. And ideally, it's important for evolution. So having multiple approaches is always handy. Like when we are thinking about applications environment, we have multiple approaches. Like environment, again, we can go for cloud architecture or for a data center architecture. So likewise, having multiple approaches even for data storage would be helpful. And also, compared to previous years or compared to the past years, now NoSQL solution is more acceptable to the customers even as compared to the previous years. The definition of NoSQL DB. That NoSQL DB is ideally defined as a mechanism to store data and retrieve them in a model which is totally different from the relational database management system, or rather, it's completely different from the tabular structure. The need for NoSQL DB is to have a simplified design and also have horizontal scalability, or called as sharding. So it helps in when there is an exponential increase in the number of users, or when there is huge increase in the data. When there is huge increase in the data, the NoSQL DB could be helpful. Why do we go for NoSQL DB? When Google, LinkedIn, Facebook, they have started growing, they have huge amount of data to store and huge amount of data to be processed. In those cases, they felt like RDBMS was not an ideal solution, because once it reached a certain point, it was not expandable and it was not it didn't help in scalability. So they tried to find different ways of storing the data, and that's when NoSQL DB came into picture. And with the advent of cloud like Amazon S3, the storage solutions had to be more reliable and also more scalable. So that's when rise of NoSQL DB came into picture. And also like shifting to dynamically typed language, like I said before, Ruby or Groovy, Ruby on Rails, all these dynamic language help in designing applications quite faster. And the next one is NoSQL DB being an open source community. As of now, most of the NoSQL databases that are available in the market are open sources, unless nowadays like IBM and Oracle are coming up with their own NoSQL database, which could be commercial. And the three important concepts that are driving the internet recently, which is mobility, big data, and cloud computing. So these ideally needs these three concepts which predominantly drive the data. One is a flexible data model, like rather than RDBMS ideally has a rigid data model, which is hierarchical. So having a flexible data model will help in better performance. And the next one is dynamic scalability. It will help in having more number of users and also store more data. So with the increase in number of users per day in most of the applications, it's always important to have dynamic scalability. And the next one is improved performance. In case of to have an improved performance, it will always help it will help in satisfying the users, because most of the users would want highly responsive applications, and also they want also the developers would want to have more complex processing of data. there are four different types of NoSQL databases. Ideally, it is categorized into two major areas. The one is key value, the other one is schemaless. So key value, the databases that are available currently is, some of the databases that are available currently are Amazon S3, Voldemar, and Scalaris. So the key value databases are ideally or simplest NoSQL databases. In this case, how the data is stored is like every single item in the database is stored as an attribute name or called as key along with its value. So there are also like some NoSQL database which is called as Redis. It actually allows each value to have a type, for example integer, and it helps in adding the functionality. The next three are column-based, document-based, or graph-based. So these are ideally schemaless, and the data is mostly unstructured or semi-structured. So in case of document databases, it pairs each key with a complex data structure. It's ideally called as a document. And these documents can have many different key value pairs, again internally. And these key value pairs will ideally store the data. Most of the document-based databases ideally supports JSON or BSON, which is binary JSON object. And these objects can be easily processed by the web applications. And in case of accessing these applications, we would use an API approach rather than using CRUD-based operations. Next is column-based. So column-based databases ideally are used for optimizing queries over large data sets, and it stores columns of data together rather than storing them as rows. So almost all the data is stored as columns, and the retrieval happens via the key. The next one is graph-based, and it helps to store information about networks, mostly social connections. And these graph stores are widely used whenever there is a relationship data. Examples of column-based, NoSQL or Cassandra. For document-based, CouchDB or MongoDB can be used. For graph-based, mostly it's Neo4j or GiraffeDB. The advantages of using key value database. It's ideally very fast, and also it's very scalable because we have a key and the key is associated with the value. And it is a simpler model. We just have a key value like a hash map. And also it has the ability to distribute horizontally. And this key value databases always comes up with cache mechanism. So the retrieval of data is easier. The disadvantage of using this is if it cannot be modeled easily, and also if the data is huge, having multiple key value stores will again impact the performance. The next one is schemaless, as we discussed, the three databases which are graph-based, document-based, or column-based databases. They are ideally schemaless, so there is no rigidity, or it's very easy to access the data, and there is eventual consistency in most of the databases. But at times there are databases like MongoDB which provides strong consistency, and most of these databases are distributed, and it helps in scalability. So it's easier to scale these databases, and also it provides excellent performance because we will directly access the data that is stored. Like for example, if a JSON object is stored, we will access the JSON directly rather than going through each, like in case of a relational database management system, the data would be segregated and put onto each table. So ideally we will perform a join, fetch the data, and then process it. In case of a document based, the entire data would be stored as a single object, so we can directly access that object. So again, the cons, it doesn't provide ACID transactions, which is like it doesn't have the atomicity. The consistency is relatively less, and isolation or durability it doesn't support. So ideally there is no joins. So there is redundancy of data. So each data is stored as an object, and if the same data can be there on the other objects as well. So coming to the database model, NoSQL database model. In case of NoSQL, in case of relational database, the data is, as discussed, the data is segregated into multiple tables and stored. So there is this primary key or foreign key which will relate the data between one table and the other table. So in case of multiple data to be stored, or we will be creating multiple tables and then normalize the data and then fetch the data accordingly. If you, in recent times, the agile methodology has grown prominent, and most of the projects are implementing agile. In those cases, the development is rapid and the schema changes like very fast. In those cases, if you take a RDBMS system, if you are changing the schema, or say when you're changing a schema, if you have to add a new column, again we end up changing the entire structure of the table. We add a new column, again normalize the tables, and we go for downtime as well. But in case of NoSQL, we have a flexible data model. So if we have to add a new column, we just add it along with the object. So it's a lot more easier, and being flexible helps in quicker development. But the problem with NoSQL data model is that there will be duplication of data. And also, the duplication of data is ideally because there is no strict definition of data format. And most of the NoSQL databases supports JSON and also object mapping. So retrieval of data using APIs is easier. Next is the elastic scalability feature. In case of RDBMS, when we have multiple, when there is increase in data or users, at certain point, if there is increase in users at the application tier, it's easier to add more and more web application servers and cater to the needs. But in case of database, it's mostly vertical scaling so that the data gets added up onto the same machine. Yes, there are cases where scalability can be done using SAN storage, but then the complexity and the cost involved is huge. And also looking at the fact that most of the applications should be highly available, and most organizations expect 0% downtime. Going for scalability on relational database management system is very difficult. But in case of NoSQL database, since it's built from the ground, or rather from the scratch, it's easier to increase the capacity and just scales out so easily. For example, to just give a comparison, RDBMS might not scale out that easily on commodity clusters, but the NoSQL DBs, which are primarily designed to take advantage of the new clustering concept, it can just scale or provide sharding in a faster way. So what are the advantages in choosing a NoSQL DB? The first one is it's relatively cheap and it's easy to implement because it's programming language. So we just store the objects as a key value pair. So we look for the key to fetch the data. And most of the NoSQL databases that are available in the market currently are free of, open source. So it's easier to implement. And the next one is a scalability feature. The data is replicated to multiple nodes, so it can be easily partitioned, and also the data can be replicated across multiple nodes. And there is this also gives to important thing that it has no single point of failure. Like I said, sharding is easy, so it becomes easy to distribute the data across multiple servers. And it doesn't require a schema, so which ideally helps in faster development, because whenever there is a change to the schema, because the schema is so flexible, we can just add up one more element or node to the document. And also it can scale up as well as it can scale down, which is more important in case of cloud architecture, because in certain organizations there could be the need where there is a huge spike at certain period of time, and there could be a place where the application would not be completely used at all. So in those cases, the cloud architecture, which helps in scaling up and scaling down, the NoSQL DB could come and help. Then there is the data consistency has an issue, but then the MongoDB and certain other NoSQL databases support consistency, like Cassandra supports eventual consistency. And then auto sharding, like it helps in most of the NoSQL database supports auto sharding, so it can easily scale up and provide scalability. And when we are choosing a NoSQL database, it's important to consider the analysis part because there is redundancy of data. So it can help in real-time analysis, but then for business intelligence or data analytics, it might not be helpful. So what are the cons, or what do we lose by going for a NoSQL database? Ideally, the CRUD operations like join, group by, order by, it doesn't support because the entire data is stored as an object, and there is also redundancy. So ideally, it doesn't support joins and other CRUD operations, and we lose the asset part of RDBMS, which is ideally it doesn't help us in the consistency, and also it doesn't help us in atomicity. And the next, like explained, the most important part is data warehousing and analytics. NoSQL is not helpful, but there are cases where it can be used along with some other product to help in data analytics, like MongoDB or NoSQL DB could be used with cloud computing systems like Hadoop, wherein it could fetch the data from the NoSQL, process it, and dump it into RDBMS, and then it can be used for data analytics. So it could be used in combination with other products to provide data analytics. And also, there are most of the applications that are there in the market have easier or direct support with SQL, like IBM or Microsoft products directly supports integration with databases such as Oracle or DB2 or Sybase. So in those cases, if we're going for a new database system, we ideally have to build it from the scratch. And also, SQL sometimes could be frustrating, but then it is the most powerful query language. So whatever we want to process, we can do it with the SQL. So where would this NoSQL fit in? It will mostly fits when there is huge amount of uncontrolled or unstructured data, which are unstructured data that is available. Ideally, in case of mobile apps or the social networking sites where huge amount of data is there, which can be disregarded after a certain period of time, or some data that has to be collected and analyzed only for that particular period of time. So in those cases, NoSQL would fit in, and that really helps in log analysis. It all, like I said, it helps in social networking feeds. It also helps in external feeds, which we collect from the different types of third-party vendors. So organizations which integrate with multiple systems and get the feeds from those partners, they can go for a NoSQL DB because those data is not relatively used for data analytics. And the next one is the data that is not analyzed, like except other than real-time data, anything that is not archived or that doesn't have to be processed in the future, we can go for a NoSQL database. Okay, considerations when we use a NoSQL database, it's like whether the data is deployed on a NoSQL platform or RDBMS, it's important to have a DB or a sysadmin who helps in troubleshooting. So when you have a NoSQL database, ideally the data that is stored can have some issues. So it's important in an organization to have the experts to look into the issues. And also we have to look at backups and recovery because certain data has to be stored and archived, and capacity planning, like say when there is an increase in users, how do we shard or how do we scale the database layer. So that has to be taken into consideration. Again, performance monitoring, because huge amount of data is there and it is important to monitor the performance. And integration of data, because there is redundancy and multiple data is stored. It becomes critically important to analyze how each data is integrated with the other objects. And the next one is tuning and optimization, like the data that is stored could be tuned based on based on the design of the applications. And now the next topic would be NoSQL and the recent trends, like the recent trends that include mobility, big data, and cloud computing, how NoSQL could fit in those trends. So big data and NoSQL DB. In recent cases, data has actually become easier to capture and also access, mainly because of the API approach. like the personal user information, location information, the social network, user-generated data, sensor information. These are some of the data that is captured by organizations over the web. And developers ideally use these data for their applications, and also the organization use them to address to their customer needs, to provide customized marketing. So if we have noticed Gmail, there are ads which are featured on the right of the on the page, and even it's a case on Facebook where ads are popped up or are shown on the page based on our preferences. So all these are analyzed based on the way we use the internet. So these data, so for each user, if the data is captured, ideally there are thousands and thousands of users that are accessing the internet or the applications. So it becomes very important to collect and store these data for customized marketing. So to collect or analyze this data, having an RDBMS system might not help because it's completely rigid. So it's important to go for a different type of database which is more flexible and also which accommodates multiple structures of data. And these data that we collect is mostly unstructured or rather semi-structured. And also the point that RDBMS doesn't help in storing semi-structured or unstructured data. It is important that we go for a different data model. In this case, NoSQL helps in providing a data model that ideally simplifies the application and the database integration, and hence it ideally helps in lesser coding, and also it provides lesser manageability. The next part is mobility and NoSQL DB. Again, it's very important for organizations to support their applications worldwide, mostly 24/7. So most of the applications are live and it has to be highly available to the users. And also the study says that almost 2 billion users are connected to the internet worldwide. And with the spread of social networks like Facebook, Twitter, Google+, the amount of time spent online is actually growing. Also, if you see, it's not very uncommon for mobile applications to have thousands of new users in a day. And the times like promotions, mainly Thanksgiving, if we take Thanksgiving in USA or Diwali in India, the usage of data actually varies based on the location and time. So to cater to this increasing or rather decrease, it could be increasing on certain cases and it could be decreasing in certain cases. The concurrent, the usage of users is, the number of concurrent users grows dynamically. So organizations look for NoSQL DB. It ideally helps them to address the following needs, like whenever there is a new app is launched, or in case of Twitter where most of the people hardly go offline, so they ideally spend their time completely on Twitter or Facebook. And also in case of seasonal swings where Valentine's Day or Christmas, there is a spike in the concurrent users. And also like when a new product is released or when there is a promotion, the usage of applications is more. So the data that is collected during these times is predominantly huge. So collecting these data and accessing them or processing them for the applications and the organizations is very important. And the next one is cloud computing. In initial days, so it was like I said, the applications were built for single users. Ideally, we develop an application, we install them on our local PCs, and then run them. But over the years, like with the advent of internet, the data-intensive and multi-user applications were built. These applications are ideally like based on client-server architecture, and they mostly cater to limited set of users. But of late, mainly because of the three-tier internet architecture, the applications run on cloud and also support huge number of users. Ideally, in a cloud-based architecture, applications are ideally accessed through browser or mobile app over the internet. They predominantly use a load balancer for scalability. In case when there is an increase in load, they add another server. So the load balancer ideally spreads the load between these two servers. But nowadays these servers are not just help in hosting; they also provide software as service as well. But in the database tier, the relational databases that were initially popular didn't help in sharing or scaling. The applications or the application layer could be shared or could be scaled using the load balancer, but in case of database layer, it was difficult to scale them because because the SQL databases are ideally rigid. In this case, NoSQL databases perfectly fits the cloud architecture because it's completely built from ground up, and it also has the ability to scale out. And the database types it supports JSON, XML along with the SQL queries, so it becomes easier to use with the cloud architecture. And in case of cloud, it provides three different types. Virtual machine, it can be provided as a virtual machine image or a database as a service, or there are native cloud, NoSQL databases that are there in the market. So what are the NoSQL databases that are available on cloud? So the first, the Amazon Cloud provides Amazon Dynamo and Amazon SimpleDB. These are actually not open source. They have to be bought. They are commercial databases. And databases that are provided as service are MongoDB, Couchbase, Redis, and Apache Cassandra. So these are provided as services. And also the Cassandra and MongoDB also come as virtual, VM image. So you can use them as, these images can be cloned, and whenever there is a need to scale or whenever there is a need to shard, these databases can be cloned. So the next part is the comparison between NoSQL and SQL database. So types, if you see, SQL has only one type, where we fetch data using CRUD operation. In case of NoSQL, you have multiple data types, like we discussed. One is key value pair, the other one is document database, the column database, and the graph databases. Data storage model, the data storage is always tabular structure, where columns help in defining the categories, and the rows help in, it stores each instance of the data. In case of NoSQL DB, it ideally depends on each of these databases. So key value helps in, it stores the data as a hash map. Document databases ideally stores that, as a JSON or an XML object. Column stores helps in storing the data as a column, and graph database ideally stores the data as nodes. And looking at the schema comparison, in case of SQL, the structure and the data type structure is completely fixed in advance. So whenever there is a need to change, you have to go for a downtime and completely change. Suppose we have to add a column, we'll add a column, we'll completely change the schema, and it has to be replicated across the other systems as well. In case of NoSQL, it's predominantly dynamic. So if we have to add one more column, or if you have to add one more instance of data, we just edit the document. And scaling, SQL supports vertical scaling, so it's very complex and difficult to implement, and also it's costlier. In case of NoSQL, it is completely horizontal because it's built from ground up, so it can easily scale out. Data manipulation, how we access the data from these systems. On SQL, we ideally use the CRUD operation like select, insert, update statements, query-based language to access the data. In case of NoSQL, we use APIs. So in case of document database, we access the JSON using a REST or any API. In case of consistency, SQL has stronger consistency and could be recommended mostly for, it's, like we discussed before, it could be recommended mostly for banking or applications where the consistency is the key. In case of NoSQL, it ideally depends on the product. MongoDB gives stronger consistency as compared to other products, but then it's not as consistent as an RDBMS. So ideally, the conclusion part. So, what we discussed so far is that the needs of applications and then organization is completely changing, mainly because of the mobile apps, the big data, and cloud. And it is really important for companies and developers to store, process huge amount of data, which helps, and also taking into consideration the scalability and the flexibility of the data that is being stored. So NoSQL approach is predominantly gaining importance over the past few years, mainly because it does a flexible data model, and the the ideal data, the flexible data model primarily helps in development of applications faster and also in easier management. And dynamic scalability, it helps in supporting multiple users and also store multiple data. And improved performance helps in satisfying the users and also providing highly responsive applications, because as a user we expect the applications to work faster and provide response in a quicker time. So in short, NoSQL could be considered a viable alternative to relational databases, mainly in case of interactive mobile and web applications. Thank you. Now we can look at the questions.
Yes, Sujit, thanks for the
Yeah.
insightful presentation. I think some technical issue. Can you hear me now?
Yes, yes.
Yes. So I'm assigning the questions to you. You have to read them out aloud and take the questions one by one. Are you able to see the questions?
Yes.
And start taking them, Sujit.
Okay. The question is, how are concepts of big data and NoSQL related or different from each other? See, the concept of big data is ideally collection of more and more data. So it's not different. It's ideally about NoSQL helps in storing of data. So how to have more and more data, or NoSQL ideally helps in storing of huge data. So when you have multiple, when you are expanding, so huge data has to be stored. So in case of NoSQL, elasticity or the scalability factor helps in ideally storing huge amount of data. The next one, can you briefly explain how Hadoop uses NoSQL DB? Hadoop has a database called HBase. So it is a variant of NoSQL database. And also, in case of Hadoop, Hadoop is not directly compared with NoSQL DB. Hadoop is primarily a computational system. So we can use NoSQL database like Mongo, wherein we can wherein it stores the unstructured data, and Hadoop can be used to process the data or compute the data using its map, reduce, or big, and then dump the data into a relational database, or it can also save it in its own file system. And these data could be accessed using analytics system. Scaling vertical and horizontal, please explain. Okay, vertical scaling in case of RDBMS, it is like growing the data, increasing the number of tables. Whenever the data is growing, we ideally increase the tables, and then we kind of doesn't put multiple systems. We just use the same single database system and then use the data. In case of horizontal scaling, we just add multiple nodes, like one machine, and then we add another machine, and then we add another machine, and the scalability is increased. So in RDBMS, we can do the horizontal scaling, but then the cost is high, and also it is either implemented using SAN storage. So it becomes complex, and also there is a need for a downtime. But in case of horizontal scaling of NoSQL, there is no need for downtime because the data is easily replicated. And how to import all tables in one go from MySQL to MongoDB? I'm not sure about that. But ideally, MongoDB helps in converting the data from RDBMS to NoSQL data. how can we find a particular record? In SQL we use, the question is how can we find a particular record? In SQL we use primary key for searching, and you have a table name, and here how is it differentiated and identified. So here in case of NoSQL, the data is ideally stored as an object or a JSON in case of document store, and in case of like we take a key value pair, there is a key and a value. So ideally we access the data using the API. So we look for the key and then fetch the data. What about data warehouse purpose? How can this NoSQL be used for data warehousing? So ideally NoSQL might not be a better option for data warehousing or business analytics, ideally because it has unstructured and redundant data. So it wouldn't really fit in as of now, but later maybe in the future there could be concepts which can evolve, then NoSQL can also be a better option for data warehousing. And the next question is, how is the job market for NoSQL? The NoSQL is predominantly gaining importance in the recent times, and with mobility, and I mean most of the organizations are looking for mobile apps. I think NoSQL, I mean the job market for NoSQL is pretty good. The other question is it possible to stream data into NoSQL databases in real time? Yes, the data can be directly published to the NoSQL database because the applications are connected to the NoSQL database. Ideally, we put the data that is coming. Suppose if it is a key value database, we just assign a key and keep the value. In case of a document database, we just dump the document or the data as a document into the database. Then the other question is how to reduce database log size SQL Server. I didn't get the question. The other question is, can NoSQL suit banking data and how much secured it is for confidential data? NoSQL data is ideally not better suited for banking because, like explained, consistency is a key in case of banking related data. So, and NoSQL database is currently not a better fit for banking. But then of late, MetLife, an insurance company, has used MongoDB as its primary customer storage, customer storage. So in security wise, yeah, NoSQL is better. The next one. If I want a common database to be seen by only some users, is it possible in NoSQL? Ideally, this could be achieved through programming. So NoSQL ideally helps in storing the data. So programming wise, we can decide like what data should be stored and what data should be retrieved. The next question is, which NoSQL DB is most used in the industry? It is mostly MongoDB is predominant and it is widely used, and also Apache Cassandra and Couchbase. The next question is there any limitation in terms of data volume in NoSQL databases? There is no, limitations because you get to scale out the databases because you keep adding new and new servers. So limitations in terms of data volume, there is none. In which situations can SQL be preferred over NoSQL? The example could be banking data where consistency is more important, and also like if you are not looking at real-time analysis, like if you are looking at data analytics or business intelligence with the data warehouse, ideally SQL could be preferred over NoSQL. And the next question is, can we say that NoSQL is equipped to take over SQL completely? No, it's not an alternative to NoSQL is not an alternative to SQL. It is more as a different approach. So it can also be like both SQL and NoSQL databases could be combinedly used for an organization as well. So it doesn't take over from that, but it is an alternate, or it is rather as an approach that helps in addressing the disadvantages of SQL DB. what are the next question is, what are the Java J2E frameworks available to design applications and interact with NoSQL database? Ideally, NoSQL databases provides APIs to access. So applications, any Java application or any framework is more suited to access the NoSQL database. Cassandra or HBase, which is better and why? I mean, it's the comparison wise. Cassandra is a key value database. Again, HBase is a key value database, but then it's I mean, it's more like a data storage solution of Hadoop. So comparing both, it could relatively be like I mean, depends on the situation or the need. You can decide like which is best. So both has its own advantages and its disadvantages. The next question is, what is schema-less? The schema is the one that you normalize and get. So you define your schema. In case of RDBMS, we define like, okay, for an employee, name, age, and his employee ID. So that is the fixed schema. In case of schema-less, when we go for a JSON object, we just say name colon and then say age colon and then say employee ID colon. Suppose you want to add one more field, say, or you want to change the name as first name and last name. In case of RDBMS, you have to remove the column name and you have to add 2 columns. So ideally, you are completely changing your fixed schema. In case of NoSQL, you just edit that object or the document saying that you just remove the name part and put it as first name and last name. Okay, there is a question. I have heard that accessing NoSQL database takes time and data retrieval is not that simple and quick like we do in SQL queries. So is it that even if we use NoSQL DBs for storing huge data, but we need to dump data into some RDBMS to use for transaction or reporting purpose? See, accessing NoSQL database doesn't literally take time, or it depends on the complexity of the data or the volume of data. If there is huge volume of data, retrieval of data from retrieval of data from RDBMS is difficult because there is huge hierarchy, and also each of the tables will be interlinked with the foreign keys and primary keys. So it has to go through a lot of traversal and then get the data. But in case of NoSQL, you just dump the data as key values or documents. Yes, in case of key value pair, if there is huge amount of data, performance impact is going to be there. But if you're using a document database, the performance impact is not that much. Can we use RDBMS and NoSQL database in parallel for web application? Yes, we can use some data we can store it in RDBMS, and some like real-time data we can store it in a NoSQL database. Which NoSQL is better in terms of performance? Again, it depends on the situation and need. See, if it is like a relatively simpler data, going for a key value database would be better. But in case of huge volume of data, it is better to go for a document-based data, and storing them as either as a binary JSON or JSON would help. The next question is, do I have an example on how JSON is stored and retrieved using an API? Currently, I don't have a demo. In case of, there is a question, in case of systems like OpenIDM, it uses JSON strings as data and stores everything into one DB table like MySQL database. data is stored as a managed object. Can this be treated as a NoSQL database? So technically yes, because you're storing everything in an object, and again the schema is not predefined, so it can be treated as a NoSQL database. Yes. But in case of going for a MySQL database, again the problem would be the scalability factor. So the two major things that NoSQL DB addresses is scalability and the flexibility of data model. So in this case, there is flexibility of data model, but then scalability factor is missed. There's a question, could you please explain why security-wise no SQL DB is better? It's not, I didn't say that NoSQL DB is better in terms of RDBMS in place of security. See, each one, I mean, you can implement security on these databases, and I mean, these RDBMS or NoSQL in different, multiple ways. So it's not that one is better than the other. So depending on the, again, depending on the situation or the need of the application or the organization, we can go for a particular model. Can we store XML files in DB using NoSQL? Yes, XML, JSON, BSON, all these are supported. Is it fair to say we are storing more data than required by approving data duplicity with NoSQL? Yes, actually we are storing more data because of the data duplicity. Yes. The next question is, what do I mean by sharding and auto sharding? Sharding ideally means that scalability, or like increase in, whenever there's an increase in load, we just add another service and then expand the capacity. Auto sharding in cloud architecture with certain databases, auto sharding is supported. So whenever there's an increase in application, automatically it launches another instance and runs it. The next question is, how a fresher can enter into big data platform job? Ideally by training yourself and reading about the concepts and training yourself on the same. Can we say NoSQL will replace all relational databases in future? Can we use it for each and all applications? No, NoSQL will not be a replacement for relational database management system. It can be a complement to RDBMS. It can work in comparison. Ideally, it just because both have its own pros and cons. The advantages of RDBMS or the so certain advantages on RDBMS or disadvantages in NoSQL. So likewise, both can be both can complement each other, and one will not completely throw away the other one. What are the disadvantages of splitting database in RDBMS and NoSQL for a single application? The con would be accessing two different types of data systems. So there could be impact on the performance, because fetching some data based on the logic, we fetch some data from RDBMS and some data from the NoSQL. So there could be issues in terms of performance and also in terms of connectivity.
Due to time constraints, Sujit, I have to request you to take the unanswered questions offline, which I will share with you through email. So there are questions pouring in. If you would like to take one more question and then sum up the session for today, you can do it now.
Okay. Thank you, Aradhana. The last question I'm thinking is like, what are the different object-oriented APIs? The APIs ideally is like a proprietary or more like a structure of programming that is designed by an organization or the application that is using it. So, rather in case of here, the most widely used API is REST.
Yes, if you would like to sum up the session for today.
Yes, yes. So thank you all. Thank you for attending this session. We'll drop in the questions which I'll try to answer and post it on TechGig. Thank you.
And I'm really thankful to our guest speaker today for conducting this wonderful webinar. It was indeed a great session. I would also like to thank all our participants for their support in making this webinar a success. The recording of the webinar will be available on techgig.com by tomorrow. Thank you all for joining us today. Thank you, Sujit, for all your time. I hope you have a great evening ahead.
Yep. Thank you. Thanks. Thank you all. Thank you.
Thank you. Bye-bye.